In this video, we're going to design the unsigned integer divider that we have explained here into a Verilog code. So we need to create a new Verilog file, and let's save it as a div by 2 of power of n. Save it. So now here we have our inputs and outputs, so we must to make sure that here our input, so we have multiple bit of m and multiple bit of q, which is output, and this one is just an inside parameter, but it can be an input too if you want to parameterize this design. So let us create this module. Div by 2 and we have our inputs there, and let's end the module. So since we want this to be parameterized, we can add another parenthesis here. For example, we can have a parameter that we can change later on our design if you want to reuse this parameter. And then we have parameter of m, so how many bits will be our input value. So since we need, in our design, it will be a 4-bit. And then we can have another parameter of n, which is the power of 2. So let's just say it's 1. No, we want to divide by 1, we just call it 1. And we have our m for inputs and outputs q. And then we have our input so this is the input m, which is m minus 1 0, and we have output the output of q, it is m minus 1 minus n. And then we need to assign the output q, so we can just use assign q is equal to. So now we need to shift the decimals of m by, so this is, it will shift the bits of m by n. So let's save it and try to analyze and synthesize. So we don't have no errors here. So let's try to simulate it and see the result of this. So first of all, we need to set this as our top level, analyze and synthesize again. So here we need to create simulate this. We need to simulate this with wave simulation. So it's easier to design with a wave simulation since this is a very simple design. And then we need to insert our node. So node finder list. So we can insert all of them. So we can insert all of them, yes. Okay. So here we have our inputs and here is our output. So this is our bits and this is the output. So this is the input. So let us try to create all the combinations, not all the combinations, like the values of from 1 to 16, since this is 4-bit, from 0 to 15, and then see the result. So let's generate this. We can say 10 nanoseconds here. And then here we can say 20. 40. 80. And then we can try. So let's set as the end simulation time to 80. So see that we have all the combinations from 0, 1, 2, 3, 4, 5, 6 to 15. So let us now simulate this, see if the divider, it will divide by 2. So we go to simulation, settings. So I need to change something here on my design, but this is only if you have the same version as mine. Save and try to run the function simulation. Save it, yes. Yeah, so we see the results here now. Now we can see if we that the result resembled what we have designed. So let me just put here as a change to unsigned decimals so we can see very easier. So we can see here 1 divided by 2 is 0, but because it only takes the like real number, it doesn't take like decimals. So we can see here 2 divided by 2 is 1, 4 divided by 2 is 2, and then you have 6 is 3, 4, like you have 5, 6 to 7. So this design works as we have designed here, and we got these results as expected. So we can see that it's shifting the bits to the right. And if you go to our Quartus program, we can see that this is our design, and we have simulated this in Quartus. So we have designed this one here, and then if you have same version as mine, you can just change this one so that it works perfectly. So this one was for this video. In the next video, we'll look how we can combine all those arithmetic design that we have did in the same file.